topic is sequence and series, finding definitions of geometric series given two terms. Alright, so some vocab first. So basically, does anyone know the difference between a geometric and an algebraic sequence? No? Okay. So the main difference is a geometric sequence, basically each term can be obtained by multiplying the previous one with a constant. An algebraic one is basically each term is the same difference apart. So for example, 8, 4, 2, and 1/2 is a geometric sequence because you're multiplying by 1/2. So for example, like the 8 and 4, there's 4 apart, but 4 and 2, there's 2. While like in an algebraic sequence, 2, 4, 6, 8, they're each apart by 2. Geometric sequences are also called geometric progressions. And the constant term you have to find is the constant ratio, which is basically it's the term divided by the previous term, and that's called the common ratio. That's also how you prove a sequence is a geometric sequence. Basically, if you can prove that A2 over A1 has the same ratio as A4 over A3, lets you show that it's a geometric sequence because the ratio is the same. And when you're trying to find the general term, or the nth term, so basically you're trying to find like the formula or like the pattern, you use the general term is equal to the first term times r to the n minus 1 power. Alright, so writing geometric sequences. So the first step of writing geometric sequences, it's going to vary depending on what information they give you, but generally you have to find r first, the common ratio, and then you're going to plug that into the formula along with whatever information they're given. And in terms of simplifying, you only need to simplify it if they don't give you what term you're finding. So for example, if they say find the 20th term, then obviously you just plug in 20 to n minus 1 and you get the answer. But if they just tell you find the general term, what you're going to have to do is once you find the common ratio, you multiply n, the common ratio n, and then the common ratio by -1, and then you take the -1, that one you can find, and you multiply it by a1, so that way you don't have to remember to subtract the term by 1, and that way you can just plug in the term whatever number they give you. Alright, so if you're given the first term and the ratio, you have to remember to plug in r and a1 into the equation. So that's just example. So if you find the 20th term, so you have a1 equals 100 and r equals 1.05, so you just plug into the equation solving for the 20th term. So you put 100 for a1, the ratio is 1.05, and you remember to subtract by 1, which is 19, and you get the answer. Alright, so if you're given the first term, or like the first and second term, and that way you can just solve by placing a2 over a1, finding the r, and then you plug in a1. And again, you'd only expand it by separating r into rn and r to the -1st power if you had to find the general term. So here's another example. So see how this is the first term. So basically, once again, you're proving the sequence by putting 4 over 8 is the same as 1 over 2 or 1/2 over 1. You're finding r, you plug it into the equation, and then you solve it. Unfortunately, I picked a really small number, so sorry, it's really, really long. But yeah, it's basically just plug into the a1 r to n minus 1 power. Alright, so if you're given consecutive terms, it's going to be the same procedure as the previous one. You find r by placing the term over the previous term, and then you're going to solve for a1, and you'd expand it if you were finding the general term. So here's the example. Sorry, it's really small, but it'd basically be a4 over a3, and you plug in the answer, so it's r equals 1/6, and then you plug that into the equation, and you're solving for a1, and you get a1 equals 216. Now another shortcut, rather than just plugging it in, is if you find, you can only do this depending on what you have. So if you have the r equals 1/6, or you have the common ratio, and your number is close enough to 1 that you can just divide back, what you would do is you take the common ratio and you basically divide back however many terms. So since you have a3 and you're trying to find a1, rather than just plugging into this equation, you can just do it, because you're going 2 terms back. So it's 1/6 divided by 1/6, which is 136 or r squared, and then you multiply that by your a3 and you get your term. So it's just dividing back. And then you plug those into your equation and you can find your answer. Alright, so if you're given non-consecutive terms, so this is the kind of tricky one. So basically what you have to do is you have to plug in your equation for one of the terms. Let's say you're given a2 and a5. You solve for one of the terms for a1, and then you take that term you solved and plug it back into the equation of the other term. and then you're going to solve for r and then plug into the answers. Right, so, for example, so the fourth term of a geometric sequence is 125, and the 10th is 125 over 64. Find the 14th term. So this is an example of what I did. So basically, you see, for example, I took the 125 because I just thought that was going to be easier. So you take 125 equals a1, and then because it's the fourth term, you just do 4 minus 1, and then you divide it solving for a1. So you get 125 over r to the third is equal to the first term. Then you plug that into the equation of the 10th term, which is 125 over 64, and then you solve for r. So because it's r10 minus 1, it's r9 over r to the third power, and then you get r to the 6th, and then you divide it, and you get r equals 1/2 once you've simplified it. And then you plug that r into the a1 that you got originally, and then you can find the first term. And then you solve for a14 just by plugging in your first term that you've got and your r. And you get 0.122 in this case. Alright, so this is a shortcut that you can only use if you're given certain equations. So you guys notice that a6 equals 12 and a10 equals 192, they're 4 apart. So if they asked you to find the same term with the same distance, so a10 to 14 is also 4 apart, you could just solve for this difference and you'd be able to plug it in. So for example, so 192 over 12, if you did that, was 16. So because it's the same distance as it was trying to find the term they're trying to ask you to find, you can just multiply the a10 192 by 16 again and you get the same answer. So that's how you'd ultimately end up with the same answer, or you can again do it the long way just to check yourself. So then you'd have to find a1 by solving for one of the equations for a1 and then plugging it into the other equation, and then plugging r, and once you solve r for that, plugging that back into the a1 equation and solving for a14. So that's one way you can do it, but if you have the right circumstance and they're the same distance from each other, you can just plug in a16, whatever solution you get by putting the a10 over a6, and you can solve for a14. Alright, so finding the general term. So remember how I said you have to always make sure that once you get to the end of your solution, you have to separate it if it's the general term. So you'd solve it just like it's a consecutive number or if it's non-consecutive answers. So it'd be negative, so you just find for a1, plug into a1 to the other equation, and then solve r. And then once you get to you have both your a1 and your r, and you get to this negative to the negative 3r and to the negative 1, then you'd separate negative 3 to the negative first power and negative 3 to the n power. And then you would solve for negative 3 to negative 1 because that one you can solve, and then you multiply it by your first term. And then you get the answer, and that way you wouldn't have to remember to subtract by 1, and you can just type this in and put to whatever power number they give you. And so just to review, so the geometric term sequence is when each term can be found by multiplying the previous term. It can also be referred to as a progression. The constant ratio is multiplying a term by its previous term, and you have to find that. And that the general term, or the general formula you have to use, is the general term equals the first term times the ratio to whatever term they give you minus 1. So remember to always solve if they make a general term to simplify it, and then just depending on what terms they give you to figure out the terms and find a1 and r and plug back into your equation. And I think that's it.